Hello everyone and welcome back to my channel. Today I'm going to talk about fault diagnosis of gear trains. To be specific, in this particular Jupyter notebook or project, we are going to identify the gear tooth fault. As you can see in this particular photo, there is a gear, this is a gear, and some tooths are missing in this particular gear. And when this is running, or when this is messed with another gear, something like this may result in a very bad catastrophic incident if we let it happen and the fault is not diagnosed before time or at adequate time when it occurs in the system. So this is what we are going to do today. Before showing the dataset that we are going to use in this project, let me show you where to get the dataset. So the dataset I'm getting from this particular link from the Gaggle. You can download the dataset, it's about 70 MB, and the description of the dataset is also given here. The dataset has two files, healthy condition and broken tooth condition. Inside the healthy condition, there are 10 more files, each corresponding to a particular load condition, which is told here that each file corresponds to a given load from 0% to 90% in a step up 10%. So if I show you the dataset, this is the gear dataset you will get after unzipping the file you downloaded, and inside you have two folders. In broken tooth, you have B refers to broken tooth. 30 Hz is the sampling rate of the dataset, and 0 is the 0% load. Then 10% load, 20% load. Similarly, in healthy, the first letter H signifies healthy. 30 Hz is the sampling rate, and then 0 is the load condition. 0, 10, 100, so on up to 90%. The first thing you need to do is you need to rename this. I'll tell you why you need to rename this in the later. You just need to change the name 0 to 00. Same you have to do in here as well. That's it. So that is the one tweaking you have to do. Then you can just follow the Jupyter notebook I have created. Alright. Let's see here. So to give an idea of what is load, usually there are two motors which are in mesh, and this is the load you can see here. And to simulate various load condition, because in practical situation the load is never same, it keeps on varying as the operation goes on. So they have given us a dataset for different load condition from 0 to 90% of the load this gear mesh supposed to carry. Alright. So let's see what is inside our dataset. I'm using the first broken tooth dataset, that is for the 00 condition. There are 4 columns, A1, A2, A3, A4. These are basically the acceleration data which are obtained using the accelerometer sensors. Those were mounted on the axis or the axle of the gear. Alright, so this is it. But we cannot use directly this one in a machine learning dataset. As we know, we don't have any labels till now. So we need to make our dataset. We need to pre-process our dataset according to a machine learning algorithm so that we can train and test it. So finally, I want my dataset to look something like this. What is this? A1, A2, A3, A4 are the original acceleration data we already have. Load is the percentage of load acting on that particular one. So I normalized it. In the original dataset, you have 0, 10, 20 up to 90. So I just normalized it into 0 to 0.9. And the final is the fault. If there is a broken, if it is from the broken tooth dataset, then the fault label will be F. It is from the healthy dataset, the fault label will be H. This is how I want my dataset to finally look like. So let's see how we are going to do that. So first I'll go to my broken tooth directory, which is this one. I'll just copy this one and paste it there. Here. And then I'll use os.walk function on this directory to get the root folder and all the files inside. If I just run it, it will give me all the files inside that particular directory. That we can see there are total 10 files, each one for the each loading condition. And this is all for the broken root, that means the faulty dataset. If I just print root, this is my root file. Then I'll use os.path join to join this root folder with the first file. So my path looks like this right now. So I can just I can use this path. Right now I can just use this path to read this particular CSV file. Okay, this is more df temp how it looks like. It is A1, A2, A3, A4 columns. Right now I'm just operating on the first one. Then I'll show you how you can use a for loop to iterate through each and every one of them. Okay, if I just plot the first axis, this first column or the A1 column, it looks something like this. It is a vibration data. This is how it looks like. That is it. Okay, then my goal is to create this column, this load label. This load label, it will be different for each file. So I need to create this one. And in order to do that, I'll use this particular block of code. So for that, I'll show you what this one. Let's see what file I is. This is this name. If I do this, so it gives me 90. That means the load condition. Then if I just do int of the same thing, I'll convert this 90 string into an int, as you can see. And then by doing 100, I'll get the point. So this label has been created. Alright, so I'm going to do this. I'm going to repeat this 0.9 for the entire df temp dataset. So right now my df temp is this one, as you can see, and I'll repeat this one for the entire dataset. Right now the value of I is 0, so it will be 0. This will be 0 as well. Just put 0. Okay, so my load column right now is a vector of length similar to this df temp, where it will have the same load condition, that is the 0 load condition. And then I need to create this fault label, as I am in the fault broken tooth dataset. This broken tooth dataset, I'll put F as my label. That is a faulty label. I'll use the same column here, and this label will be my F. That's the faulty one. Okay, now I've got two columns, like my load column and my label column. Now I just need to add these two columns to this df temp dataset. I'll use this function. So doing that, right now my df temp dataset looked exactly the way I want it to look like. It is a load column, it is a fault column, and that's it. But the problem is right now we have only did it for the 0 dataset, or the 0 condition dataset for the broken tooth condition. But our goal is to iterate through each one of them, each 10 of them, and then not only for the broken tooth, we need to do it for the original, like the healthy condition as well. So for that we need a for loop. Alright, and this is the for loop I'm going to use here. So what is this I in range files is going to do? It is going to iterate through every file, like the 10 load condition we have, it is going to iterate through that. Then I'm going to join with the root file, the same thing we did previously. Initialize a df temp, the load column, the label column, then I'm going to append those two columns in my df temp, and then finally concatenate it. What is my df? Initially I created this df. This is just an empty list containing the same number of columns, containing only the 4 columns that was in the df. And finally this function will return my df. Alright, this make dataset function. Once now that is created, it takes two input. One is the directory and next is the lab is the label for the dataset. So I'll give you an example. Just give the directory name here that I created before, and as this is the broken tooth, I'll give label equal to f, and the directory, it has two input. If I just run it, okay, so now if I just run it, it will run through each one of those. So now my PDF F will look something like this. Now I have it has iterated through each load condition. So now my data set has, so finally my data set has all this value concatenated over one over another for the entire broken tooth data set. All that's what I wanted. Same I'm going to do for the healthy. For that I'm just going to change the directory name to the healthy folder and then label to H. Then I'm going to run this one and to see the DFH. Now my fault is the healthy condition fault there, and all load conditions are concatenated one over another horizontally. Then I'm going to concatenate this fault label and healthy label one over another and make my final dataset, that is dear, and save it in this path called gear fault data.csv. So that is it. That's it for the data pre-processing stage. It will take a while and the dataset will be a little bigger. It's like 80-ish MB of data.